Hello, everybody. This is going to be the answers to midterm review number 3. Midterm review number 3. All right, so let's draw a picture here. So this is essentially a bird's eye view. We're going to have a curve that kind of goes like this, right? More of a circle here. So we're going to have a car. Those are the tires as if we were looking down, all right? And they're going to come around like this. So the key thing to appreciate here is that the radius of curvature is going to be 75 meters, okay? So this is going to be 75 meters. This car is going to have a mass of 1,000 kilograms. And when we look at this car from the back, okay, this is going to be our angle. So notice in these first few questions, the angle is going to be flat, okay? So I'm going to draw it flat to begin with. So we're just going to be, okay, so that would give us 0 degrees. And we'll kind of draw it at an angle in a second. So if the car was going 17.1 around the curve, calculate the centripetal acceleration. So you may remember here that centripetal acceleration is equal to v squared over r. 17.1 squared divided by 75 meters per second. And we're going to say 17.1 squared divided by 75 is going to give us 3.8988. So we're going to call that 3.9. Okay, so 3.9 meters per second squared. So our answer to number 1, the centripetal acceleration is 3.9. We'll call it 3.90 meters per second squared. And that's our centripetal acceleration. So number 2 is calculate the centripetal force. So remember, when we multiply mass times acceleration, we're going to get centripetal force. So all we have to do is multiply by mass. So in the case of this car, it's going to be 1,000 kilograms. So our centripetal force is just going to be 1,000 times greater, which is going to be 3,900 newtons, and that would be the force. Okay. Now, if the car was going 17.1 around a flat curve, 0 degrees without skidding, calculate the coefficient of friction. So remember, if it is going to accelerate, okay, there's got to be some force that's going to make it. So when you're on a flat curve, something has got to push you towards the center. Otherwise, you're going to want to go straight. Newton's first law. An object in motion will continue in a straight line motion unless acted on by an outside force. There's something's got to be pushing you towards the center. So when it comes to a flat curve, it has to be friction. So when we look and draw the free body diagram, we're going to have mg going down. We're going to have our normal force going up. And so our force of friction is going to go to the middle. And the sum of the forces in the y is going to equal to 0. So remember, this car is not going to move up and down with respect to the vertical. Okay, it's not going to levitate or sink. Therefore, it equals 0. So we're going to have force normal minus mg is equal to 0. Therefore, force normal is equal to mg, which is going to be 1,000 times 9.8, which is going to be 9,800. 9,800 newtons is equal to the normal force. Now, if we check the question here, that is not the answer, but it's partway to there. So remember, we want to know the force of friction. Okay, so we're going to go in here. Just like here, we're going to have the sum of the forces towards the center is equal to mv squared over r. Okay, now what that is going to be the force of friction. The force of friction is going to be going towards the middle, which is going to be mu force normal, and that's going to be equal to mv squared over r. So remember, we already figured out that our normal force, our overall centripetal force was 3,900. And we know that our normal force was 9,800. And so if we say 3,900 divided by 9,800, that is going to be our mu. So 3,900, which came from the mv squared over r from number 2, divided by 9,800, which came from calculating our normal force, and we're going to get a mu to be 0.398. 0.398 is equal to our mu. Now, I'm not really specifying between coefficient of static friction or kinetic friction, but this would actually be static friction, because as you move around a corner, you don't want your tires to slide. They're not going to slide. So even though they can be moving in a roundabout way, moving left and right is going to be 0, and that's really why it's static friction. Again, I'm not going to ask you that, but our coefficient of friction is going to be equal to 0.398. And we are now ready for the next question. Okay. Now we are going to talk about a banked curve. Okay. So now are going to have our tires essentially going up at an angle. And in this case, that is 30 degrees. And again, if you look here, it's still going to have this radius of 75 meters. Okay. Now it's saying, what is the minimum or maximum velocity that you can go without friction? Okay. So now we want to look at our free body diagram, but it's going to look a little bit different here. Okay. So again, we're going to have our mg going straight down, and then our normal force is going to be perpendicular up there. And if we now talk about the sum of the forces, we're going to have the sum of the forces towards the center is mv squared over r. But remember, this direction is towards the center. Okay? This is now going to be the direction in the y. So if this angle is 30, then this angle is 30. So now we're going to have the sum of the forces in the y. Now, this car, again, just like before, is not going to levitate or sink, and therefore this part is equal to 0. And we're going to have this component right here. Remember, this is the hypotenuse, that's the angle. So this one right here is going to be Fn cosine 30 degrees. That's going up, Fn cosine 30 degrees. minus mg is equal to 0. Therefore, force normal is equal to positive mg divided by the cosine of 30 degrees. Okay? Now, we're going to look at this one now. What's going to make this one go towards the center? So if this was force normal cosine theta, this is going to be force normal sine theta. So force normal sine theta. That is the only vector. That's the only vector that's going towards the center, so it has to equal this. Okay? Now, we know what our normal force is, and that is going to be mg. So we're going to replace that right there, and we're going to get mv squared over r is equal to mg over cosine 30, but we forgot times sine 30, and now we can cross out the m's there, and so we're still looking for velocity. So we're going to simplify this. So sine over cosine is tangent. So we're going to have g tangent 30 degrees times r is equal to v squared. And then we're going to take the square root. We're going to take the square root of 75 meters times 9.8 meters per second squared times the tangent of 30 degrees. We're going to let our calculator now do the work here. So 75 times 9.8 times the tangent of 30 degrees. That's equal to 424. We want the square root of that answer, and we're going to get 20.6. So our velocity, which is both our max and our minimum, is going to be 20.6 meters per second. Now, it is the maximum velocity because if you go any faster, then your car is going to be moving, sliding kind of up the road. But if you're going too slow, okay, it's going to slide down the road. So right at that 20.6, you would be at equilibrium between sliding up and sliding down. Okay, and that is going to be your answer for that question. And so that would be 20.6 meters per second. All right. Now, what if the car is going only 10 meters per second? Okay. What would that angle be? So remember, we're not going as fast, right? So then this angle right there would be unknown. But now we would know the velocity. Okay. So we're really going to take this. We're going to take this equation right here, and now we can say v squared over r is equal to g times the tangent theta. So if we divide both sides by g, okay, then we're going to have v squared over rg, and then to get rid of this tangent, we're going to have inverse tangent, and that will give us theta. Okay, so now we can say inverse tangent of 10 squared divided by our radius, which is 75 meters, and times 9.8, and So 10 squared is 100 divided by 75 divided by 9.8 gives us 0.136. Inverse tangent of that answer, it's going to give us 7.74 degrees. So theta right there is going to be 7.7 degrees. Okay, so if we're only going 10, then that minimum maximum velocity would equate to a lower angle, which is 7.7 degrees. All right, so now if the car starts with a velocity of 0 and ends up going 17.1 meters per second around a flat curve, calculate the tangential acceleration 1/8 of the way around the circle. Okay, so again, we're kind of going back to this one right here, okay? And let's get rid of this. Hey guys, I realize here that this should have been going in the other direction, okay? Because it should be going towards the center. So kind of the way I drew this, it should have been kind of going the other way, but you guys still get the right idea. All right, so now we want to think of this car going around here. So we know that there is going to be a centripetal acceleration, okay? And we already know that that is 3.9. We already know that that's 3.9. Okay, but we're going to have a tangential acceleration, and we're going to have this 1/8 of the way around, okay? Now, this really is going back to a kinematic equation in which we're going to have V final squared is equal to V initial squared plus 2AD. So it already said that it's going to start out at 0, and we already know that it's going to end up being 17.1. And we know that the acceleration, we don't know the acceleration because this is the tangential acceleration. And how far does it go? What is the linear distance when we go 1/8 of the way around a circle? Okay, so we know the circumference is equal to 2 pi r for all the way around. So if we want to be 1/8 of that, it's going to be 2 pi r over 8, which will reduce down to 4. So pi times r divided by 4, pi times 75 divided by 4, and that's going to be the equivalent of the linear distance to calculate tangential acceleration. Okay, so pi times 75 divided by 4 is going to equal to 58.9. So our distance is equal to 58.9 meters. 58.9. So now we want to solve for this. 17.1 squared divided by 2 times 58.9. That's our tangential acceleration. And that's 2.48, okay? 2.48 meters per second squared. That is our tangential acceleration, okay? So I'm going to get rid of this for now so that I can do a little bit better job of showing you the next part of this question. All right, so remember we were at Kind of going back to 5. If you go too fast, you're going to fly off the road, either on the low side or the high side. Number 6 was 7.8 degrees. Question number 7 was 2.48 meters per second squared, which is what we just got there. Okay. Now, question number 8 from question 7, what is the magnitude of the total acceleration? Okay. Now, remember that we already knew that this acceleration towards the center was 3.9 meters per second squared from the very first answer. And now we're going to end up having this right here is the total acceleration. So remember, these are at a right angle. Okay, so we know that this towards the center is 3.9. We know tangentially is 2.48. Okay, we could do it up here as well, make this 2.48 and this 3.9. But regardless, we're going to have the total acceleration, which is calculated just by using Pythagorean theorem because we have a right angle. So our acceleration total is equal to the square root of centripetal acceleration squared plus tangential acceleration squared, 3.9 squared plus 2.48 squared square root, and 3.9 squared plus 2.48 squared equals square root, and we're going to get 4.62. So our acceleration total is 4.62 meters per second squared. And finally, number 9. 4.62 meters per second squared. And finally, number 9, we want to know the angle. Okay, we want to know the angle that total acceleration is going. All right, so what we're really looking for here is either this angle or this angle. Okay, but it specifically says we want to know the angle with respect to the radius, so we want that theta. Okay, so that is going to be the inverse tangent of the opposite, 2.48, divided by the adjacent, which is 3.9, and 2.48 divided by 3.9 is 0.63, inverse tangent of, inverse tangent of 0.6. $32.47. We'll round that to 32.5. 32.5 degrees. And finally, 32.5 degrees. And that's with respect to the radius. All right, ladies and gentlemen, there is all your answers for midterm review number 3.